We had many examples these couple days, and you know, often behind the starting business, you are the child dream. Me, when I was young, I was really impressed by planes. They make me dream. You know, so that sometimes, more often, the pursuit of your dream doesn't follow logical paths. So I became a chemist. And during the beginning of my career, I've learned how to make new materials with chemistry. And it's almost 20 years after my childhood, we have developed in our lab a new process able to make high-performance material for aircraft engines. So we create Norimat. And we try to use chemistry and performance at the service of the new plane generation. We operate here, in the hottest area of the engines. Here, the manufacturers, to reduce the fuel consumption, they have chosen new materials as titanium alloy. They're lighter, they're more efficient, but their implementation is very difficult. They need many expensive steps, and including post-machining treatment, which waste a lot of this high-value material. If you focus on the blades, with usual technique, you can waste up to 80% of the powder you purchase initially. With the solution we develop, we want to invert this ratio. Our process, our innovative process called spark plasma sintering, based on powder metallurgy, able to make the parts directly near net shape in one single step. And with that, we can lose less than 10% of the powder we bought initially. The parts we make, they come out of a furnace called Dr. Sinter at more than 1300 degrees. It's a bit sophisticated. Let me say that you can say it's the Formula One of the furnace. But we know perfectly how to use it to develop new materials. And what we want now is take it out the lab and to make a real process production. I've just told you that the parts came out the furnace, but I could have said they come out from the head of our associate, Claude Estournes. He's a French researcher, but he's one of the third world leaders on this technology. And he has recently applied for a patent for the design of these complex parts. And so with this patent and with our know-how, you have here the hardcore of the team able to drive this Formula One and push it to the maximum capabilities. Today, we work as a technical department for different big clients to prototyping the parts and also enhancing the material property. We have three main goals. Of course, understanding the theoretical phenomena involved, manufacture the parts, and also scale up the process. And today I'm very proud to show you our first prototype we developed. It's an helicopter turbine blade. We get that in less than 1 hour directly with the target geometry and a very high control of the properties. And to conclude, that's finally a good example of what is motivates us to develop and design these materials and use high chemistry for the future of the aeronautics. Thank you.
Thank you, Romain. In the field of blades, for example, I think one of the Graal today is a CMC, so ceramic composite. And is this technology compatible with the manufacturing of CMC?
With this process, we can work with many materials. The easier for us, for the moment, is just to reproduce what is already existing, to convince that the process is available and we can make the same even better. That's the first step. After, when we're confident with the client, we can design new things with us.
When you start to talk about this kind of part, the blade, you're really you're really working on the core parts of those devices. So that's very strategic. Under the control of some of my colleagues who are running the fab, who are doing that. So how do you intend to work with several customers in this field at the same time? Don't you think that some of the players quickly will ask you for a kind of exclusivity? So how will you be able to scale up a company?
Exclusivity is not a big deal. It depends how much you paid. We are just on the beginning, so we are firstly we need to prove everything, and we'll see. We'll meet all of the actors after, but they need proof to believe us. So for now, we don't have yet a strategy to see everybody, but yeah, we will work on.
Would you see this primarily being used in manufacturing or in on-demand maintenance?
We can address many markets, so we will manufacture some parts in certain markets, and maybe after we will develop all the process and sell all the process with the machine to other markets. Depends our strategy we choose.
And will you sell the machines or sell the materials?
So we will develop the materials. The machines, they are already commercialized, but we are in negotiation with the producer of the machine to sell all the package.
Thank you.